talk a little bit about functions of two variables. Kind of really ties in with what we're talking about, because function of one variable is what we're used to, y equals f of x, and then we're graphing on the xy plane then with the independent and then the dependent variable y, and so you get whatever function it is based on those input and then output values. Well, when we go to two variables, of course, then we'll generally call it x and y. There's some other examples in the book, though, with some applications, I guess, that are pretty interesting using some other variables. But anyway, those two are input values, and therefore the z value is the output value in those cases. And so then you get a three-dimensional, which is what we're kind of been talking about all along here, and a curve or plane or whatever it is comes out of inputting x and y, and then output is your z value, is really the big change or the big difference there. All right. And so a couple of things they get us to think about. Just like here, our domain is the x, the output is the range, the y's. Over here, the domain are going to be, they're going to have to be ordered pairs. You're going to have a combination. Those are the input values, and so that'll be your domains. And then, of course, the range then are the z value. So let's think about domain for a two-variable function. All right, so just for example here, let's think about what is our domain for this particular function, x squared plus y squared. F of xy equals x squared plus y squared. And it's the same question we've always asked: what values can we input for the x and the y? And of course, here we're focusing on real values, real value functions. And so in that particular case, is there any restriction on the x or the y? No. So your domain, different ways you could write it, but in this case we could just say it's I think the book likes something like that. The real values for x and y can be input. Now, on the other hand, the range of these values, let's think about that. Since both the x is squared and the y is squared, and we're only talking about real values here, real numbers, that's going to be positive, that's going to be positive. Or the only other thing we could have, if x is positive or negative, x squared will be positive. If y is positive or negative, the y squared would be positive. And so you're just going to get a positive number in that case. The only other option is both of them 0, 0, 0. And so, the range here, when you put those two together, you're only going to get positive numbers or 0, no negatives. So the z values would be greater than or equal to 0. I think they'll probably write it in interval notation in this case. So, so it's really the same stuff. You just have to think about a few more things. Let me mention this one. On this one, now, we do have a few restrictions on the x and y. One, I guess, for each, but x can't be 0 and the y can't be 0. And so typically the way they'd write that is you write the set of x, y's such that x is not 0, y not 0, something like that. To designate that can't have zeros there. And then if we think about the range here, what about the range on this one? Yeah, you're going to get any number. You can get positives or negatives out of this particular setup expression. And so the range can be any number except, yeah, you're not going to get 0 out of that. 1 divided by a number, you can't get 0 out of that. So the range would be all real numbers except your 0. Okay. Now, those we didn't do any graphing of the domain or the range. I guess we think about that. If I graphed the domain here, just the domain now, it's a set of ordered pairs except for x is 0, y is 0. So what would that be? If I shaded all the domain there. Everything except 0, 0 or an axis, right? Y equals 0 is the y-axis. Y equals 0 is the x-axis. X equals 0 is the y-axis. So it's everything except those axes. I don't know if they'll have you graph one like that, but so it's a little hard to see on that, but you're leaving off, and essentially you've got dotted lines separating those. So I guess we might should draw those in too, but all right. Okay. Here's another one. Okay. Let's say f of x, y is square root of 100 minus x squared minus y squared. And so really, we're just looking at the same restrictions we've always had. Can't have denominator 0, and so you have to throw those out. And in this case, we've got square root, and the square root, you can't have the square root of a negative number. And so when you're talking about the domain of something involving a square root, yeah, the inside part has to be something greater than or equal to 0. And so that sets up this inequality, which, let's think about it a little bit. If we put it in a little different format, we can see maybe what that domain is. Let's move the x squared and the y squared over to the other side, and that would be and switch that around a little bit. Flip it the other way around. 100 is greater than or equal to x squared plus y squared, which means x squared plus y squared is less than or equal to 100. And so, look at the graph of the domain on that. Well, x squared plus y squared equals 100 is a circle, radius 10. And then the less than part would be, it's not my best circle ever, but there's a little better. Okay. A little happier with that one. The less than part then would be what? The inside part. So our domain is everything in the interior of that radius 10 circle there, centered at 0, 0. And the way we could write that then is something to that effect. It's a set of all the ordered pairs x, y, such that x squared plus y squared is less than or equal to 100, or 100 minus x squared minus y squared is less than or equal to 0. Something to that effect. And then, of course, our range here. I might ask that. Obviously, we can't have any negatives, so it's going to start at 0. We could have if we were on, say, we're on the 10, 0 point here, or 0, 10 point. X is 0, y is 10. That would put us at 0, right? So we could get a 0 out of this. But could we go, how much further could we go? To infinity? Or well, if you think about it, if you go to 0, 0 here in the, it only goes to 10, okay. Yeah, 0, 0 is going to be about the smallest you can get, or is the smallest you can get. X is 0, y is 0 will put you at the square root of 100. And so that that is going to be your greatest value there. So, all right. One other one here on this domain range stuff. F of xy equals the ln of xy. All right, what do we have with natural log? Logarithms, you can't have same thing. Basically, same thing as a square root, except in a square root you can actually have 0. And so, but with logarithms, you can't have 0 or negative, right? So in a logarithm, you need the inside part to be strictly greater than 0. Which, sometimes that sets up an equation to solve. But on that one, we can just kind of think about where is the product of x and y greater than 0? Which quadrants, in other words? You'd have to have both the x and the y positive, right? So quadrant 1. Or both negative, x negative, y negative. And so it turns out the domain is quadrant 1 and quadrant 3. And it doesn't include any of the axis points either, so strictly quadrant 1, quadrant 3. So that would be our domain. The range here, about the range. Well, do logarithms have the values of logarithms? We can get positives and negatives, can't we? Yeah. Logarithms can be positive. The result of logarithms, you can have positive or negative values, and so yeah, it turns out the range here is everything. Yep. All right.